Hello friends. In this particular video, what I'll do is I'll first tell you about the numerical differentiation, that is how we perform numerical differentiation, and then with the help of a function, we will be developing a mathematical function. That is a very easy thing for you now, and then we will be differentiating that function for a particular value of let's say it is a function of x, so for a particular value of x. So to start with, let me tell you about what is numerical differentiation. So let's say y is a function of x. So if y is some function of x and you are here and you wanted to know what is the value of y after moving certain distance h or dx, let's say h, you wanted to know what is the value of this function. So the first thing is that the lazy man approach. You can simply say, okay, the function value at x is nothing but x plus h is nothing but x only. That's it. But you can see that you are very much lagging behind by the exact value. So second thing is, okay, let us try to find out the slope also. So this is df by dx and then multiplied by this h will give you this value. But still, if you increase, if you further, let's say this is the graph, you are here, this is x and this is x plus h, you try to do that, but still you lag somewhere. So then comes this curvature in the picture. So then the second derivative, that will be h square by 2 factorial, and you increase the derivatives further. This is what we call as Taylor series, and this is the expanding the function around this moving in forward direction. So now friends, we can also do this thing while moving in backward direction, that is x minus h. So y x minus h will be fx minus df by dxh plus d2f by dx2 h square by 2 factorial minus d3f by dx3 h cube by 3 factorial and so on. So if you take the first series, that is forward direction series, so this is a backward direction series. So if you take the forward direction series, then what you can write is y x plus h. Now what is y x plus h? That is nothing but the value of the function at x plus h. Okay, so f x plus h minus fx will be equal to df by dx into h plus d2f by dx2 into h square by factorial 2 and so on. So if you divide the whole equation by h, then you will be in a position to know what is the derivative of this function with respect to x. And here the terms are what? The first term will be having term h because this will cancel out, so it is h. Then the next term will be having h square and so on. So as h is less than 1, so the highest order term is going to be h. So basically by truncating this part, what we are doing is we are writing this df by dx as fx plus h minus fx by h plus the terms which are having order h. So order of accuracy will be h. So as let's say h is 0.1, so the we will be accurate up till 0.1 decimal after decimal this much. Now if you look this particular thing, that means if you move in backward direction, so this is called as forward difference. So if you move in backward direction, what you will be getting is fx minus f x minus h by h plus the order will again be h. So this is backward difference, moving in backward direction. You can very well do it with the help of this equation. So what you'll do is you'll bring this here and this term will come that side and hence you will be getting this expression. So this is first way of differentiation, this is second way of differentiation. But their order of accuracy is less, they are less accurate. But if you add these two, if you add or subtract, no, if you subtract these two equations, then what you will be getting is another way of differentiating the function x. So that you will be getting as fx plus h minus fx minus h divided by 2h. This is what you will be getting once you subtract this. And here, if you subtract, so this h and this h will become 2h. So that's why in the denominator you are getting this 2h. And what else? This h square term will cancel out, but the remaining will be h cube, then h to the power 5, then h to the power 7. So the highest order term which we are going to truncate here is of order h square. So if the value of h is 0.1, then the error will be of 0.01, which is lower in comparison to this and this. So this is much better approximation. Here we are doing what? Here we are taking, if this is x plus h, and this is x minus h. So in the first case, we are moving in the forward direction. In the second case, we are moving in the backward direction. Whereas in the third case, this value is evaluated based on forward and backward both and is at the middle. So this is called as central difference. Okay, so using these informations, we will be doing what? We will be evaluating the differentiation of a function. That means first differentiation. And let's say you are interested in knowing what is the second derivative. So you do what? If you add these two equations instead of subtracting, so this term and this term will cancel out. And the first derivative which you will be getting is of second derivative. Therefore, the second derivative of this function with respect to x will be fx plus h minus 2fx plus fx minus h divided by h square, and this will also be having an accuracy of h square. So in this way one can do what? In this way one can perform the differentiation. So in this video, till this point only, in the next video what we'll be doing is, in the next video we will be first developing some mathematical function and then using the concept discussed here to evaluate the first difference as well as second difference at a certain value of x with certain value of h. Okay, so thank you very much for watching the video.